Ma'am, we will take a few minutes to enter the participants because the participants is less here. So we allow them. Once they will come in the majority, we will start now. We'll take few minutes to start the session. Good afternoon, ma'am. We have with us our Honorable Director NIMT wants to share our views.
Hello, good afternoon.
Good afternoon.
Good afternoon, ma'am. First thing, I welcome you at this 3-day workshop
Thank you.
on remanufacturing. It's my pleasure, which is organized by National Institute of Advanced Manufacturing Technology. And we have recently started a forum. We call it Futuristic and Advanced Manufacturing Forum of India, because we have different forums in different areas of technology like metals, mechanical engineering, but particularly with the focus on manufacturing, we do not have some platform where we can interact, we can exchange like that. So we joined together to organize this particular workshop. And we are really grateful to you for readily giving your consent. Now, we are expecting, now it is 43. Actually, here today, we have a particular, we call it worshipping. We worship the god of technology. We call it Vishwakarma. So,
Okay.
yeah, and it is Engineering Institute, and many of our students and colleagues are a bit engaged in that. And so I think they will gradually come up. So, I mean, as you know, remanufacturing as an area, I came to know about this area only about 6 months back, right? And
Okay.
it was a very unique opportunity. There is one organization called University Grant Commission in our country who control the higher education here. So for one issue of recognition of our institute, they asked us to 5 master degree program which are not offered in other institute in the country. So that was really a difficult task, because we have more than 4,500 engineering education institute in our country. So to figure out some area which is not taught in institutes like IITs and ISC Bangalore, perhaps you are familiar about. So it was difficult task. So there we could identify some area called remanufacturing, and gradually it attracted our attention for its uniqueness. At a glance, people consider it is other name of repair, other name of reclamation, but it is actually different. It takes some time to present that. So it is not yet rife in this part of the globe. For example, India, although it is well in China, but in many countries it is not yet ripe enough.
Absolutely.
But for whoever have joined so far, now it is 73. So for them, I would like to mention, if you try to Google remanufacturing in whatever area you are interested in, maybe business or technology, whatever it is, you will find name of Dr. Wang appear within first 2-3, depending on the subject area you are searching for. So Dr. Wang is one of the most popular researcher, technologist globally in this particular area, and he is one of the couple of people who have initiated. I know, Dr. Eric Sandin, perhaps you have come across
Yeah.
him. He was the speaker yesterday. He submitted his thesis, PhD thesis in remanufacturing in 2004.
Yes, he is. Yeah.
You were the couple of people who could visualize it, and indeed, I'm sure this is the future of sustainable manufacturing. There is no doubt about this. So we are really fortunate. We are happy. We are delighted to have you in this forum. Thank you, ma'am. We are looking forward to your lecture. So now we have a comfortable audience. It is 78, and we have another 25, 30 in the YouTube, right? So
Thank you very much. Thank you
I
very
will
much.
request Dr. Jageshwar Verma to present a brief introduction about you.
Thank you, sir. And once again, welcome, ma'am, and I welcome to all the participants in this session 4, this remanufacturing industry 4. So before we go to the sessions to the honorable speaker, it's my indeed privilege to introduce Dr. N. Wong, principal lecturer in the University of Brighton, UK. I'm Dr. Jageshwar Verma, coordinating this session. So Dr. Wong research direction is remanufacturing, which adds value to the waste stream by returning items to working order with case study on automotive, machine tools, rolling stock, etc. She has published more than 50 high impact journals paper and been granted 10 patents. She is a committee member of BSI technical group. Dr. Wong has research experience in engagement with policy makers in remanufacturing, including BEIS, Innovate UK and Chinese government. Example, her engagement with policymakers in China and the UK has been listed as one of the policy outcomes of 9th UK-China Economic and Financial Dialogue. Dr. Wong is going to deliver a lecture on intelligent remanufacturing, the case of industry applications. It's our proud privilege to have her today as the honorable speaker in these sessions. I owe to these sessions to ma'am. Ma'am, please.
Thank you very much. Thank you for inviting me for this lecture. I found it very, very helpful, and also it's a very good platform to be able to outreach outside the UK, in the in an international level. So thank you very much. I'll start share my screen right now. Can you see my screen?
It's visible, ma'am.
Can you see it now?
Yes, it's visible.
Excellent. So today's topic, we'll talk about intelligent manufacturing, which is focused on industrial applications. So first, before I talk about the details, I would like to introduce my university. My university this is the UK map, and here is London. We are very close to London. It's only 1 hour by train, and it's a very beautiful area. We have sea, coast, beach. We also have history. We have Royal Pavilion here, where used to be the princess, lives in Brighton. We also have history, a lot of art shops here. So it's a very popular area, in Brighton, and for English people to come to visit. It is a tourist attraction area as well. So I do hope you could come to visit me in Brighton, not only for remanufacturing, but also for the culture and the history as well. So for today's lecture, I will be covering the below topic. First, I'll give you an overview of remanufacturing. I do apologize if this has already been covered by the other lectures. And the second topic, I'll summarize the challenge opportunity. But this is also based on my first-hand evidence I have from the survey of companies. And the last topic, the next topic, we talk about specifically my research and these industry applications of my work, especially intelligent remanufacturing. The last one is we talk about what I feel is the future. So by definition, which I'm BS 887, I'm a committee member for that standard. Remanufacturing is return, is an industrial process that return used product to at least as good as new with the same kind of warranty as new. Remanufacturing is the way you can return value. So it's the end of product, we return the value of end of life product rather than scrap them to the raw materials. So it's a much higher value added process compared to recycling. There are a lot of confusion between remanufacturing and some other similar term, for example, refurbishment or reuse or repair. I would like to use this diagram to show the difference. So first one is repair. Normally repair is within the first life and it doesn't change the ownership. And then remanufacturing would expect the same amount of life compared to previous life. But refurbishment is a bit lower form of remanufacturing. It does return end of life product back to life again, but doesn't guarantee the same amount of service life. And directed reuse is just, like you sell a product on eBay, somebody else can want to use it, or you do some sample kind of cleaning, you really use them again. So it's not the same level as remanufacturing. Remanufacturing is the highest level for reuse. So if you look at the waste, the hierarchy, remanufacturing is very high level compared to reuse, and recycling is definitely much higher level compared to energy recovery. And it is also, you reduce the waste, and you can save up to 8% of materials energy compared to the new product. So if you look at globally, the really remanufacturing in the global level, the largest market for remanufacturing is in the US. Then the second one is in the EU, and in the EU, the most has the most remanufactured in Germany. Then is followed by the UK, France, and Italy. If you look at outside the US or EU, the next area will be in Asia. Asia is one of the biggest area and the fastest growing area in China, in the whole Asia, and China is a major area in that one. So if you look at the sector distribution, the biggest area is really aerospace, and then followed by the automotive, then is followed by the heavy duty off-road machinery, then is followed by other, for example, furniture or repair industrial medical equipment. So that is the distribution. However, if you look at the intensity, which is defined as the ratio of remanufacture to manufacturing, actually, remanufacturing is very, very low. Is only 1.9% of the virgin manufacturing. So there's a lot of work has to be done. I'm not surprised if somebody saying, I have never heard of remanufacturing, because this sector is such underrepresented, and it is not widely recognized as the industry as being existing. So it's a lot of a lot of activity in the background, but a lot of people don't know about that. So having talked about remanufacturing, I would like to talk about the challenge for remanufacturing. So if you look at the remanufacturing process, you would have the start from end of life product. That is the feedstock for remanufacturing. Then they go through the remanufacturing process. For example, like disassembly, cleaning, inspection, and repair, and the reassembly, and then repackage. Then they deliver to the customer again. They become remanufactured product. If you're looking at this horizontal value chain for remanufacturing, then there are a lot of potential issues. For example, the biggest problem for remanufacture is they don't have enough channel to collect end-of-life product. As a result, they don't have enough product that organize remanufacturing. And that has a problem, you know, if we could work on the research, will be work on the reverse logistics or looking at the e-marketplace to collect, you know, like the Amazon for remanufacturing to collect the coins or to collect the used product. If you look at the remanufacturing process, the biggest issue for remanufacturing process is uncertainty, because either the feedstock for remanufacturing is end-of-life product, and you don't know when end product going to fail, and you don't know how many going to fail arriving for remanufacturing. That is make it extremely difficult for remanufacturing process, because the company who have to organize resource, they don't know how many going to arrive and how would they organize the resource to dealing with this. As a result, you would say, okay, the remanufacturing is really ad hoc. They can't plan at once. As a result, you cannot have the same amount of efficiency as manufacturing. As a result, the efficiency or the remanufacturing efficiency is, you know, is only 1/3 of that compared to manufacturing. Therefore, that tells me there is a lot of, you know, research need to be done to make the remanufacturing process agile and efficient. And then if you're looking at the, you know, at when the product is remanufactured, and they also have a lot of issues. For example, a lot of people doesn't know there is, you know, remanufactured, they don't understand there is remanufactured product, and they feel remanufactured product is kind of a second-hand, and that they don't trust the quality of remanufactured product. Sorry, what happened here? And also they are, you know, they are not having no confidence of a remanufacturing product, and that tells us there is a need of research to get the quality assurance, to look at the warranty, as well as, you know, how to accreditation. When somebody claim my product is as good as new, you know, how do you know he does the job? And they will be need the quality assurance as well as accreditation process for the remanufactured product. There's another problem with remanufactured product is there's lack of sales channel for remanufactured product. That tells us we need an e-marketplace for a remanufactured product, similar to Amazon for the new product. Right. If I want to look at vertical, look at product life cycle, because remanufacturing start as end of first life, and this is the starting point of the second life. So the first life will definitely affecting how the product is being processed and going to be used at the second life. So if I'm looking at the first life, product we experienced, for example, design, manufacturing, operation, use, and then become end of life. For each of them, you have, you know, for example, they have their own problem. First is the big challenge is product is not designed for remanufacturing. They are designed to reduce cost. They're designed for mass production, but they're not designed for remanufacturing. As a result, is product is very difficult to be disassembled. If you want to disassemble, at all time you just have to break it, have to destroy it. So they're not designed to be remanufactured. A typical example probably is Apple phones or Apple computers. The next one is when you're doing the manufacturing and operation, the data is not shared with remanufacturing, because remanufacturing, you know, the business model for remanufacturing, a lot of time they are kind of subcontracted. They're not integrated into the product life cycle. So the OEM have all the information for the design, for the manufacturing, or the user has the information about how it's being used. But this information is not passed to the remanufacturing. So the remanufacturer has no idea what has done for this product in the previous life. Therefore, they cannot make an informed decision what they can do for the process, or whether or not a product is reusable for the second life. So that is a very big issue for them. So in addition to the vertical supply chain level, production level, or to the horizontal, vertical in the life cycle level or horizontal in the production level, there are a lot of non-technical issues. For example, the legislation. A lot in the EU, a lot of end-of-life product that be treated as waste. If they're treated as waste, they have a lot of limitation. What you can do for a product. The second one is about the trade. There are a lot of limitations on what you can do for the, for the end-of-life product. If you want to import, export the end-of-life product or remanufacture, they might have to, for example, import the end-of-life to be remanufactured and then to be exported again, to be used again. But there are a lot of countries has limits on the trade of remanufacture or the trade of end-of-life product because they're treated as waste. They also have a problem with the standardization, accreditation, because there are some standard, as I'm part of the committee member of the standard, we are developing some standard for the BSI, but the standards is very, very limited. There are also a lack of awareness of a trust, because as you said, you only you only know the remanufacturing 6 months ago. Yeah, and a lot of people will probably doesn't know remanufacturing until now. So there are also a confusion of remanufacturing and refurbishment because that is like awareness of trust of remanufactured product because they think of it's the same as refurbishment and they don't trust the quality of the remanufacturing as well. So this is just giving you a summary of what's the problem with remanufacturing. And we also have conducted some national survey of remanufacturers to get the first-hand information, what exactly is the problem for them. So this is a survey we have did last year with some other partners about the barriers facing remanufacturers. And this is participated by 20 plus companies. And what they told me is that the biggest problem for them, this came from company directly, biggest problem for them is user behavior or perception of this, remanufacturing as a second hand. And the second big issue is technical data from OEM, because the original manufacturer don't share the data, how the product is made, what is materially used, what is manufacturing specifications they have for the first life. This information is not passed on to the remanufacturer. So who have to do it from scratch? And then the last one, the next one is the legislation and the certification is, this is what we mentioned about, remanufacturing is, end-of-life product is treated as a waste rather than an asset, available to be used again. And the cost, remanufacturing cost is normally as 3 times as compared virgin manufacturing, simply because it's an individual process and it's ad hoc process. So that is why they're far more expensive than manufacturing. If you look at there are quite a lot of challenges, then okay, why people are still doing that? And then there are also a lot of opportunities for remanufacturing, the drivers for remanufacturing. So again, we did the survey again. We surveyed the 20, I think about 25 remanufacturers. We are asking them what are the biggest driver they would like to consider as for the remanufacturing, and the majority of them come to say is the sustainability, material efficiency, circularity for the remanufacturing. This is the biggest drive, especially in the UK. I mean, the net zero is part of the legislation, and the company have to do much more compared to used to do for the net zero, reduce the carbon emissions. And remanufacturing offers as alternatives for them as a kind of for them to reduce the carbon emissions. So that attracts a lot of attention at this moment. We also surveyed last year about 190 remanufacturers, and 46 responded to our survey. And we asked them, what are the technology innovation will help you most for them to increase the productivities? And top one for them, is designed for VRP, which is for remanufacturing, reprocess, refurbishment, repair. And most of them feels this is the number one priority. That suggests that OEM or range of product designer must take into consideration for the end of life before when they design a new product. And that is the most important part for that. And the EU legislation, the right to repair, has forced the OEM, the designer must have to think of what they're going to be and make them repairable for end of life, and that will help for this design for VRP. The second one, most important one for them, is life cycle analysis, tools and method. And that is exactly addressing the issue I mentioned earlier, is the life cycle data is not passed on to the remanufacturer. So some of the product, for example, already have embedded sensor. They have a lot of data available now. For example, what is the service condition, how long they have been used in the previous service, how often they have been maintained. All this information is not passed on to the remanufacturing. So that is a big issue now. In addition to that, because company has to declare the CO2 emissions for the production, and they will also need to understand what kind of CO2 emission they can save if they use remanufactured product, and there is not much tools and method available for that process. Then the next one for the survey is the technology intervention for them is the VRP process technology, is the value retention process technology, for example, like inspection, like the cleaning, like the repair, and how can we improve the efficiency and how do we address uncertainty for the remanufacturing process. The next one to the technology intervention is automation. How can we make the process automated, then to improve the efficiency? So that is kind of what the company tells us, what they feel the most useful for them in terms of the technology intervention. Right. So in addition to this, information directly from company, there are also a lot of top level kind of drive for remanufacturing. The first one is the increase in awareness of the benefit of the remanufactured product. I mean, now more and more people starting to get interested in that, and mostly is for the UK. The most, the very hot topic for company is the global supply chains, and there are quite a lot of issues with global supply chains after the COVID. And for the UK, they have a unique problem is Brexit, because they're leaving Europe. The supply chain is much serious problem for them. So they are suddenly realized that remanufacturing actually could be a solution to address the disruption of the global supply chain. In addition to that is the government commitment to the net zero, and the circular economy can contribute 45% of net zero, and the remanufacturing is a very critical part of the circular economy. And that is at the top level. And in addition to that, the consumer, they're becoming increasingly environment conscious. They want to say, when they buy a product, they would like to get more information about the environmental carbon emission footprint of the product. And remanufacturing could also attract the attention as well. So in all of them, to address the challenge, to deliver the benefit of remanufacturing, realize the opportunity of remanufacturing, intelligent manufacturing, remanufacturing is the key to address these challenges. So now you want to say, okay, we talk about the problem with remanufacturing. We also explained the opportunities in remanufacturing, but then the next one is, what is the solution? What do you mean by intelligent remanufacturing? I mean, I think you have been very familiar with the pillars for the, for the intelligent manufacturing. But to me, I would like to say focus of the intelligent manufacturing should be 3 areas for remanufacturing. First is the life cycle data integration. So that is, we need to develop a mechanism or business model or method to be able to access the data from the first life for remanufacturing, for example, the design data, manufacturing data, operation use data, maintenance data. They need to be passed on. There should be some mechanism to be passed on to the remanufacturer for them to use it. And the remanufacturing based on this data, the manufacturer can based on this data to decide how they're going to do the remanufacturing and whether or not an end-of-life product is worth remanufacturing or not. And also, because I mean, you're probably very familiar with predictive maintenance, they should also have the same level of the work for predictive remanufacturing. So we can know when a product should be remanufactured rather than only look at where product should be maintained. So that is a key area remanufacturing, intelligent remanufacturing should be looking on. The second one is look at the future remanufacturing factory. That is trying to address the problem with uncertainty. You don't know when a product is coming and how many is going to be coming. What is the quality of the incoming end-of-life product for remanufacturing? So the future remanufacturing factory must be flexible and must be very, very kind of, has to be mass customized. They have to deal with individual process, individual quality, and calculate and have the algorithm to generate a customized remanufacturing process. And then we look at the supply chain integration. At this moment, you have, remanufacturing is outside the supply chain for a product, and it has been neglected. But as the value chain, as well as the product life cycle, remanufacturing should be part of the supply chain for the product. They need to be integrated rather than at this moment isolated outside the product supply chain for the first life product supply chain. So let's have a look at the University of Brighton's work, and all the work I have, I'm proposing here, the work we have done here are in partnership with companies, with company applications, and there are a lot of work need to be done for the remanufacturing. Probably need more work to the remanufacturing than manufacturing. And I would like to talk about what we have done, but there more need to be done. So first, what we're talking about life cycle analysis for a reprocessed medical device. So this is the example, the EC cassettes for the medical product, and we provided this information to NHS. So basically what we did is we conduct a life cycle analysis of these cassettes for the virgin product. We also do the life cycle analysis for remanufactured product. We want to see how much CO2, how much emission we can save if you use a remanufactured product compared to the virgin product. And then the result tells us if you use a remanufactured product, you could save more than 50% of CO2 emissions. And this result, we will pass this result with NHS, which is the National Health Service in the UK, for them to look at more, provide informed decision whether or not they should procure remanufactured product because it's cost saving as well as CO2 emission saving as well. We follow ISO standard and as well as NHS standard, and the raw data, primary data for analysis came from industry directly from, for example, Association of Medical Device Reprocessing, as well as a remanufacturer called Innovative Health. So after we talk about life cycle analysis, we also worked on the factory, intelligent factory, and for this case study, we're using the rolling stock, talking about the flexible rolling, how we repair end of life defective product for rolling stock components. As you can see, the component like that, they are retired at the overhaul process. Each of them, they are individually. So they have to be repaired individually. And at this moment, they have been done manually. We are looking at, can we do something more flexible, adaptive, and then make them automated? So what we did is we developed a kind of a hybrid process, adaptive robotics remanufacturing. So what we did is we have, for example, we have end-of-life product, defective products. We use a 3D scanning. So we reconstruct the digital model of the product. We develop algorithm to compare this defective component with original component. Then you can see calculate where's the defect. And then based on the defect, we create the tool paths to repair the material deposit, the missing materials. And then we do the sensor machining to machine them back so you got a smooth surface. So that is the overall framework. So really is the research question, the very big challenge is if each component is individual, how do I identify what kind of failure it is? It could be failed by, for example, the corrosion. It could be failed by crack. It could be failed by, for example, fracture. How do I know which failure it is? And I need to identify accurately and then quickly for remanufacturing. Second one is, how could I generate a repair strategy for a robot to do the repair according to the identified the failure feature? So you're talking about, which repair parameters I should use, and what is the tool path, the movement of the cutter I should, the welding deposition, for example, for the repair of the defect area, and then to do what is the tool path for the sensor machining, because I want them to be automated. So what can I do with that? So to do that, first step is to identify the failure. So as we said, what we did is we use a 3D scanning to scan the defective model, and we compare with the nominal model, and we develop algorithm to compare. We're cutting them into layer by layer and compare each layer what is difference between them, and that will allow us to extract the point cloud of the damaged regions, and that is extremely useful for us because with this point cloud of the damaged region, that place, we can calculate where is the failure location, what is the failure model, because we look at the geometry. If it's very long, very narrow, you might be saying that is crack. If it's very patchy, you may say that is corrosion. And we also, based on that, we can calculate what kind of failure volume and how much material I needed to use deposit for the deposition, and where I'm going to do the repair for the sensor machine for the good service, surface, as well as what kind of failure degree is that serious, or they should be scrapped at all, or is that worth repair, or it might be not worth, don't need to repair at all. So that will allow us to make decisions and do a lot of things that is very useful for decision making. So the next one is we have developed an algorithm. So this algorithm tells us, for example, we automatically identify the area that is missing from the component, and as shown in the red color. Once you have identified the area that you need to repair, then we can look at how to repair. And this is also an example we use how we could automatically identify the parts that need to repair. As you can see here, we deliberately break down this, the turbine blade, and then we use 3D scanner to scan them, and then you reconstruct the CAD model, and then our algorithm automatically identify the area that you need to repair. So we have been convinced that we can identify the failure automatically, but the next question will be, so what? What are we going to do with this information? So the next one is, if we know which part needs to fail and where is failure, we needed to decide what kind of repair route, steps, and parameters for a repair. And that one is very much experience-based. So instead of, we would like to say, okay, how can we reuse knowledge? And that has been used before, and then we regenerated the knowledge for the new component for the repair. So we have developed some tools which automatically, so once we have incoming parts need to repair, I look at or generate a database, record all the previous decision making. Then we search what has done before, and then we compare, can we use the same route, same steps, the same parameters for this new, for the new component that need to repair. And then we, based on that one, we can quickly decide what is the cutting, repair parameters. Then we can look at what we can do to the toolpaths. And we have also used the same kind of methodology to use, and rather than only for the rolling stock, we also use the same kind of methodology to use in different sectors. For example, we use machine tools. We use the same kind of decision maker. We record what has done before for a similar component in terms of cutting, repair parameters and the repair, severity degrees, as well as the route, how they've been repaired. And we use the same methodology for the machine tool as well. We also look at, once we have done the software, so we know the algorithm to detect the defect, you're using the algorithm to identify, the previous parameter that has been used. We use the, for the toolpath, how they've been repaired. Now we look at how could we develop the hardware, the robot, to integrate the software we have developed and into the repair. And we are working on the repair of the fuel tank for that as a case study. We have, this is ongoing PhD student, he's been working on that one. In addition to the repair, in addition to life cycle analysis, we are also been working on the disassembly for reuse. So we got the end of life laptops, and we want to see how long does it take us to repair it, and where is the problem for the repair. And apparently the OEM does not really take into consideration when they design the laptop, for example. As you can see, there are so many different sizes, so many different screws and nuts for the laptop, as for example, and that makes disassembly extremely difficult and inefficient, and make the cost for the remanufacturing very high, and make it probably not worth remanufacture. And in addition to that, we are also working the e-marketplace to address the problem. There's a lack of channel for the remanufactured product to get the coins, get the end of life product for remanufacture. So we have worked with a company. We developed an e-marketplace online platform similar to Amazon. We have developed an e-marketplace, and we develop this, and we have formed a company to commercialize it. And this company has been recommended as one of the 4 clean technology company to be watched by Digital Catapult, a government organization, in 2021. So having talked about the remanufacturing challenge, the drives, and remanufacturing research, then what is the future? I would say the future is bright, and I would say it is, what we have done is, to be honest, just scratch the surface. There's so much more need to be done. If for remanufacturing, if you want to achieve the remanufacturing the future potential, the remanufacturing has to be as the same efficiency as manufacturing, and they have to be, the cost has to be the same as manufacturing. Otherwise, remanufacturing won't be competitive, and people want to use remanufacturing. And as you know, so they has to be as good, as efficient as manufacturing, and a lot of technology has to be invested to make it happen. So that is really the end of my lecture. Before I finish this lecture, I would like to invite you to put papers for this conference I am chairing next year. So this conference is the world only remanufacturing academic conference, and it will take place in Amsterdam, together with Remantec. If you don't know Remantec, Remantec is the world's largest remanufacturing exhibition in the whole world, and it's normally participated by 7,000 professionals from all over the world. And the data for the conference is 27th to 29th of June 2023. We do welcome you to put papers for this conference. I will be circulating this promotion materials with the stakeholders. So I will send the invitation to you as well. Thank you very much for your attention.
Thank you very much, ma'am. Thank you very much for your worthy lecture on this remanufacturing, the case of industry and the applications. You have very well explained about the solution to waste management, remanufacturing barrier, and also you have very well focused on the intelligent manufacturing, which is a key of to address the challenges and realize the opportunities. Thank you very much, ma'am. And also we will submit in the next whatever the conferences, international conferences on remanufacturing is going on. Definitely we will submit our
that would be great. I will send you the information to you later.
Thank you, ma'am. And now we'll look for the question answer sessions. I request to all the participants, please you write your question in the question answer box, or you may raise your hand. We have one question. Could I read, ma'am, or you will look it?
Can I look at myself, the questions, right? Oh, yeah.
Yeah, Rahul Kumar. Could I read?
Yeah, so the question is, as you have mentioned, that we can remanufacture a product that is equivalent or better than that of a newly manufactured product. Then my question is why we cannot make a better product while remanufacturing a new product, while we're adding the value for the product after getting the fault in the product. We should add the value in the early stage where we can avoid to some extent. That is a very good question. I mean, that is, I would say, this is the business model. Because at this moment, OEM, they design the product, they manufacture the product, then somebody else use the product, and then the remanufacture is at the end of life, somebody else is outside OEM's control. So OEM don't like people to remanufacture their product. Instead, they make it harder for remanufacturer to remanufacture the product because they want to sell as many new products as possible. So when they design the product, most of the time the consideration is how do I reduce the cost for manufacturing? They don't care about the end of life because they are not responsible for the end of life. Somebody else is doing that. So the value is not as well. This is a supply chain integration problem because remanufacturing currently is not part of the product value chain for OEMs, and they don't care because for them it is not to the best of their benefit because they want to sell as many new products as possible. Does it make sense to you guys? Have I answered the question here?
I think the question is answered, ma'am. Another Anirudh Oran is there. He has one question.
Yeah, I have this is really good question about the fact. Is there any publicly available data on the environmental impact of the remanufacturing process that can be leveraged for this adoption? So just for your information, I mean, there are very little research on the environmental impact of remanufacturing. And I have a paper in the field. I'm happy to share with you in this one. And we are recently working with your remanufacturer for a medical product to quantify the environmental difference for remanufactured product compared to virgin product. But there's very little research in the field. They definitely need a lot more work in the field. I'm happy to share with you my research paper that has been published. And we have another one, for a medical product. We expect to be published in November, so there will be more coming.
If you permit, we have another one question.
Right. How is augmented reality related to intelligent remanufacturing? I would say that probably more related to the remanufacturing process. At this moment, remanufacturing is, as I said, very low efficient, the individual, and it's impossible for remanufacturer to plan the process operations. So if we have augmented reality, we could simulate in advance and plan in advance, and then make sure right at first and optimize the process to reduce the cost for remanufacturing. Because at this moment, remanufacturing process is 3 times more expensive than manufacturing.
Thank you, ma'am. We have another participant, Swetang Yadav. Swetang Yadav, you may ask your question.
Yeah, sure.
Are you hearing me? Swetang Yadav.
You unmute.
Swetang Yadav is here.
Skip that. Skip that.
Okay.
Nandita.
So, Dr. Nandita, ma'am, are you listening? You may ask a question.
Madam, are you there? So I think there is some communication problem.
Okay.
So participants may mail their question to us, which we'll be happy to communicate to Dr. Wong, and you can have your reply.
Yeah,
Yes, ma'am. Proceed, ma'am.
Yeah, ma'am.
Thank you for inviting me for this, because I feel India is sometimes underrepresented in the remanufacturing community, because I see a lot of activities from America, from other, like EU, like in China, even in some Japan, also a lot of activity. But I don't see many activities or papers from India. So I'm really glad I'm here to be able to talk to you about that, because I would love to see more paper and more presentation, and from the India to see I'm part of the global society for this remanufacturing. So I'm so pleased I'm being invited, and thank you very much for today's presentation.
Thank you.
Thank you, ma'am. Thank you very much for your enlightening presentation. It's my privilege to present a vote of thanks on behalf of our esteemed organizations. As everyone know, that this international workshop is going to jointly organized by NIMT and the Futuristic and Advanced Manufacturing Forum of India. And we would like to express our gratitude to Honorable Speaker Dr. Yan Wong, who has spared her precious time for us and graced this occasion with her vital appearance. Thank you, ma'am. Thank you once again.
Thank you very much. Thank you.
Thank you, ma'am. Now we have our next honorable speaker, Dr. Naga Hanumaiya, sir. So before we to the sessions to Dr. Naga Hanumaiya, sir.
Yeah.
Sir,
Dr. Hanumaiya, welcome.
good afternoon, sir. Can you hear me?
Yeah, yeah.
Yeah, please.
Absolutely. So I welcome you on behalf of NIMT and FMFI. You are part of both, so it is just formality. Yeah, Dr. Hunumaya is having, we will have a detailed introduction of Dr. Hunumaya, but from a personal experience, I would like to share that he has really on-hand experience in manufacturing. Earlier, he was in a great institute, CMERI Center Mechanical Engineering Research Institute. Now he is heading CMTI. So he has a vast experience. And Dr. Hunumaya, I'm happy that you have appreciated our effort to look into the manufacturing. As Dr. Wang has said, although there are a lot of activities going on around, China started remanufacturing activities since 2005. UK has already doing a lot. Germany is also doing, Japan is doing, but it is not yet ripe enough in our country. So I'm really delighted that people like you, expert like you, have taken interest. So we look forward to listen from you. And I will request Dr. Jageshwar Verma to give a brief introduction of Dr. Hunumaya, although it is just formality.
Thank you,
Thank you,
sir.
sir. And once again, I welcome to Dr. Naga Hanumaya, sir. It's my indeed privilege to introduce a noted eminent researcher and administrator, Dr. Naga Hanumaya from CMTI Bangalore, as a speaker of this session. Dr. Naga Hanumaya is the director of Central Manufacturing Technology Institute, CMTI Bangalore, and former chief scientist of CSIR, Central Mechanical Engineering Research Institute, Durgapur. Sir has completed his PhD from Indian Institute of Technology, Bombay. Sir did his postgraduate in tool engineering from Indo-Danish Tool Room, Bangalore, and engineering degree from Bangalore University. Prior to his experience in CMTI Bangalore, he had 20 years research experience at a CSIR, CMERI, and 3 years teaching and 2 years as a mold designer in the industrial tool rooms. His current area of research include micro nano system engineering, including modular micro machines development, micro nano scale manufacturing process, and biomedical applications of micro nano patterned surfaces. In the past, he has worked on dies and molds, injection molding, and rapid tooling area. He has established a research group, Microsystem Technology, at CSIR, CMERI in 2006. Sir is one of the principal investigator of the Smart Foundry 2020 project, a DST sponsored project. He was the nodal officer for the CSIR 11th Task Force on Modular and Reconfigurable Micro Manufacturing System. He continued as a nodal officer for the CSIR's Task Force on Robotics and Micro Machine during 12th FYP period. Sir is a recipient of Boy Scout Fellowship and Raman Fellowship. Sir is one of the recipients of We Think of It for India award from Prime Minister of India for the Indian Manufacturing Policy Draft prepared in 2003. Sir is the member of International Institution for Micro Manufacturing USA and International Association of Engineering UK. Apart from that, he is a professor of academic of scientific and innovative research, New Delhi, and honorary professor of Indian Institute of Engineering Science and Technology, IST, Shibpur. Sir is going to deliver a lecture on the automation in remanufacturing. It's our proud privilege to have him today as a honorable speaker of these sessions. I over to the sessions to honorable speaker, sir, please.
Okay. Good afternoon, all of you, Professor Chattopadhyaya, and all the faculties from National Institute of Advanced Manufacturing Technology. This is my privilege to talk to you, and thanks for giving an opportunity. Is it visible, my slides?
It's a visible, sir.
Yes. What I try to speak is primarily like how does this automation and Industry 4.0 technologies would help remanufacturing. Since it's already last 3 days, his event is there, and all my previous speaker, Professor Wang, also explained what is meaning of remanufacturing. I will not repeat those things. Basically, what I did is first few slides, I will talk about our institute before getting to the actual subject on Industry 4 and then remanufacturing. Some of the activity which we did and also some of the tools that enables remanufacturing will be discussed. CMTI is about 60 years old institute, established in 62, is a national research lab. We focused on machines and process technology, primarily like machines designed and developed in India first time. As of now, I think we have developed about 500 machines. Unlike other academic institutes or other research establishments, CMTI always develop the technology which ensure that this is being utilized in the actual industry. That is, I think, USP of this institute. We won't do much on the basic research. Our activities are primarily applied research, which is TRL 3 and above. We mentored some institutes, and then we authored a machine design and data book, which is even today it is kind of a reference material for all the mechanical designers. We have about 60 technologies now for the licensing. So we also serve an industry about 3,000 by providing value-added technical services. While doing our research primarily focused on these three aspects: developing a manufacturing processes, and then manufacturing equipments and the systems. The kind of activity what we do is we try to address the challenges with respect to all the 4 Ps I call: product, process, people, and production. It means our activities also have 4 folds. First is that we build a machines for the problem which is faced by the end users. Maybe they will come with the process knowledge or may not have a process knowledge, but still we develop the process and the equipments and supply. Second activity is we identified the manufacturing gaps, the technology gaps with respect to machines and process technology. And then my colleagues will build the machines and the automation systems. The third one is we also work on the ecosystem, manufacturing ecosystem, both either on the request of industry or on the request or the problems as identified by our own scientists. The third activity is primarily we provide services to the industry. If I look at the second focus domain, the first two what I mentioned, machine development, we develop ultra precision machine tools, special purpose machines. Because of time constraints, so I'm not going details. But if you look at these pictures I gave, these are all like, it is not a prototype. These are all machines and installed in the user industry. We build a machines which are capable of creating micro nano scale features with at least accuracy level of at least 6 decimal. And then special purpose machine we build. I think we build a tabletop machine to a large machines to solve the stakeholders or the end users requirements, to fulfill their requirements. So sometimes they know the process, we build a machine. Otherwise, we also develop customized process and the machines to solve their problem. So when we are building a machines, naturally sensors, controllers are built-in requirement, essential requirement. So we have a dedicated vertical which works on the sensors and controls, including measurement systems. And then textile machinery is our new entry into special purpose machine category. If you look at the second picture, that is the rapier loom. And the example for ultra precision was the first picture, that is a diamond turning machine. And then we also develop aircraft LRUs and test rigs. We design, develop a test rigs. And then precision metrology, we are #1 in the country as far as the dimension metrology is concerned. Then smart manufacturing and Industry 4, we have a dedicated vertical. I think some of my presentation today is mostly focused on smart and additive manufacturing, what we did and how it could be helpful to remanufacturing. And then micro nano manufacturing, we primarily focused on machines and devices. So we engineered, say for example, if you look at a third picture, this is a micro stereolithography machine which we build, both process and the machine developed, which is capable of creating as small as about 5 microns using photopolymers. And then we skilling and reskilling is the fourth activity which I mentioned. That is, we primarily look at imparting the practical skill sets to graduates coming from the college. We don't offer any degrees at this moment, but we primarily impart the practical skills. And then naturally technology transfer and incubation is the essential activity where we focused. Whatever we do, as I already mentioned, we look at machines, technologies developed in India, that is made in India. We're proud that whatever the system solutions we provide to our industry, it is at least new to India. So that we are is already into the Atmanirbhar Bharat vision of the government. These are the services. So we test machine tools and its aggregate. We offer a measurement and calibration services. And I will come back to the third one, the aerospace qualification test, material testing, nano manufacturing. So this is also, we are already into this re-engineering or remanufacturing of high value components. Here our focus is there are several electromechanical system and equipments which were installed by importing, but in many cases, they don't have the kind of traceability or the spare parts. Those are still equipments are kind of have an opportunity to recondition. So those things we work, we are primarily 3D printing helps us. And then we also offer the training. As I said, we don't have a degree program, but as otherwise about 55 training programs, 25 corporate training programs, then active learning workshops, finishing school for the up to 6 months, finishing school for the engineers, then summer internships, and then some online courses for a working professional. Annually, we build about, these are just I populated, I will not go through details. It's annually we build about 8 to 10 machines. So if you look at 18 to 20, the last 4 years, we build about 26 machines, and all these 26 machines are built in India first time. I think that is what we kind of our strength. So I'm gradually entering to the subject that is about CMTI, what I mentioned. Just to introduce. If you look at the remanufacturing, so before getting to remanufacturing for the better understanding, so what is product innovation? We know that product innovation essentially has a 4 distinguished kind of stages. So it starts with the research, then research is translated into a technology, and then it is required training to the person, people, or the user, or the manager, or the investor. You have to train them. Then you deploy, and while the application itself, there are other issues like maintenance, supply chain, how to increase the productivity, all those aspects. All together, I call it as a 4 piece. The challenges will related to product design, process design, people, and production. That is what I think CMTI has all the components. And this is golden rule. Any new product development or new product innovation, one has to go through this process. So naturally, why it is also known that yes, the primary driver is yes, you know how to do things with your hands. Definitely, you will be skillful. That is what we believe. And you are more free and independent individual. You can depend on yourself and your community. You are well prepared. You can stand at the technological crash and resolution. I think many of our industries have learned this during a pandemic because their entire company was fully depends on some industry or some suppliers globally. So they suffered a lot. You realize that you don't now, particularly in the post-COVID, again, these two are the opportunity area getting emerged because the cost of ownership of the technology becomes more important than the luxurious. So that is why the frugal engineering and all the people are looking into seriously even in the country now, including remanufacturing. Yes, we always, being a public funded institute, talent institute and technology developers, we always look at the technology developed in the country and if not originated in the country. And we strongly believe collaboration and cooperation. So I always look at request you people, if any of you is interested, we can always, will be happy to discuss with you. And at the same time, in a product innovation, in order to engineer the manufacturing systems. That is what our focused area. It is just not the manufacturing, but one has to clearly understood, appreciate the requirements at different aspects like product, process, people, and production. Product is more of like form, function, these kind of things will address. The process is more of fabrication. The people is involved everywhere, and production is also involved everywhere because you need a capital goods, investment machines, starting from your simple workstation to the high-end testing equipments. We also know that engineering is always like, it never be 1 + 1 is 2. At least we believe it because of this. There are a lot of other attributes. I think one has to remember, no matter whether you make a water bottle or you make a flight, one has to remember these 5 Fs. And these 5 Fs are the drivers to solve the challenges with respect to the 4 aspects of manufacturing value chain. Now, it is like, what is the remanufacturing? I think by this time, this community is already known because several researchers must have already talked about. But in simple term, what I understood is this. The conventional economy is primarily focused on manufacturing value chain. That means there is a resources, you use the resources available and make use of those resources to make a product. That product can be utilized to meet your requirements, either to add the value or to impart the comfort to the citizen. I think that is what whatever we do, finally, end of the day is citizen comforts. And then once all products have a limited life or the defined life. So once it is done, you dispose it. So what are the challenges with this? I try to list, of course, it is debatable, but it is what I could gather to best of my understanding in the manufacturing value chain. Resources are always limited because each country, each system has, somebody doesn't have money, somebody doesn't have material, somebody doesn't have a capital. So resources are always limited. And users are all continuously increasing. You can take any component naturally when the time of introduction to the maturity, definitely it is because of user. That is what the business house also expects. And manufacturing processes are becoming expensive, and cost of ownership is also increasing. But although we certified that, okay, this product cannot be usable, but still there is a residual life is there, but it is remain as an unutilized. I think that is where the people are looking at remanufacturing. So that means if you dispose the product or systems which still has a life with reconditioning, refurbishing, so it is basically you are losing a value and you are not encashing the residual value. And sometimes this disposal itself is an environmental hazard. So whether you can able to reuse some of the material which is otherwise causes environmental hazards. I think in that sense also it is important, remanufacturing is important. So remanufacturing aims at bringing end of usable life of products. Sorry, there is some small English mistake, back to good, or if not as a new product. That means the products which are already lost, means usable life is over. So can we recollect those used products that normally in the manufacturing factories, they call it as a course, and refurbish, you go through the process, then you will finally get a refurbished good to or new products. In general, remanufacturing process, this I borrowed from some literature. Basically, these are the essential. You have a course that is reusable products, you clean them, inspect them. I think Madam was, Professor Yan was already talking that. Inspect them, then store it. So then you go for assembly, disassembly. You disassemble, identify which products have a life. Each itself is a separate theory, so now getting evolved, theoretical understanding is there. And then you disassemble, study the product and reprocess it. Either you reprocess as a scrap, you can use that as a starting scrap and you can recondition and produce new, or existing component or the product itself can be reconditioned, remachined, or depositing. There are different ways. You can reprocess. That means you are importing the value which was expected or which was there earlier, somewhere rate and all there. Then you test it and reassembled. So you will get a remanufactured products. But I think there was some question was there. Don't think remanufacturing products are as efficient as the new products. Your idea is to enhance push the life of the products. That is one. And second is you can also take care of some of the issues on environmental hazards. And the third one is to reduce the ownership cost of ownership, because material is always the challenge. So it is a limited resource. So that is how the overall basically remanufacturing leads to a circular economy. So if you look at now a smart remanufacturing, means how that Industry 4 enables the remanufacturing. This picture I borrowed from this reference is a beautiful picture, is clearly explained how Industry 4 could be used here. So it starts with disassembly. So then all these four, I think if anybody is new to Industry 4, Industry 4 theory is basically depends on these 4 steps. That means it says in a simple lay language, you understand what you do based on the data which are captured from the real resources, digitize and sharing to your respective to perform the analytics. These predictions comes out of these analytics could drive the appropriate decision making or automating your manufacturing system, whatever it is. I think that is what the overall theme behind an Industry 4. And then you can call it as a smart enterprises, smart factory, or people call IIoT, IoT, whatever is there. But the overall idea is that. And this varies with company to company, shop floor to shop floor within the company, and even machine to machine. So there are several technology pillars are getting evolved. There are people are calling 9 technology pillar and 14 technology pillar and all. But end of the day, whatever the technology you develop that enables these 4 steps, I think that you can term it as a Industry 4 enabled technology. So in case of apart from the regular production, if you look at a remanufacturing, so remanufacturing, if you remember, I already told you that cleaning, inspection, then storing, then disassembly, from the again value addition, then testing. The value addition is processing, then the testing, and then reassembled. So if you look at only value addition process, these all tools are required. So that means there should be incoming registration, then it goes to repair, CAD conditioning and repairing process. Then you need to capture some of scanning tools are required. Or if you're required, you can reverse engineering or re-engineering. Then it goes to the typical manufacturing. I limited only to metal cutting, but yes, this is variants of this has to be done depending on the product, what you are addressing, from disassembly to reassembly. These are the conditions you require some of the softwares to do redesigning or reverse engineering or to generate like tooth paths and all. Then this database, this part transfer and all this is essential components of predicting and digitizing. This will come. You need to have appropriate tools, Industry 4 enabled tools. Then this needs to be shared. Then you can use the local network or the global network, public network. That is depending on the size of operation, so the scale of operation of your company. These are, then you can realize that, okay, disassembly to assembly, there are a lot of opportunity for involving or integrating the IIoT enabled tools that enables starting from product or the used product registration to capturing the data, then modifying a data through your digital twin and all people are working. Then finally adding a value to kind of generate or regenerated part that could be taken back to the original product assembly or it is a new assembly, again re-engineered assembly. Now I will talk about some of the tools which my colleagues do it at CMTI. If any, maybe if you ask hardcore technical question, maybe I will not be able to disclose because it is work is done by my colleagues, but we will be able to respond to you with my concerned scientist. I will request to respond to you whatever is can be shared. This is about the scanner. This is a capturing a reverse engineering and also the measurement. We have developed our two scanners. The left side is still not made as a product. This is basically the fringe projection scanner, which can allows you to capture as small as about 10 micron features, up to, I think, depth of penetration is up to 1:10, sorry, 1:100. And we also have this is handheld scanner. This is like video, kind of videography. You can just carry wherever you want, and then you can scan. This will allow you to capture as small as about 30 micron features. This is already product. You can look at some of geometries like scissors, the grippers, micro grippers, which we have in the order of few microns were captured here. And the tire profile, this is a dentist bracelet. And we also use some of like some components. These are all industrial components we already supplied to this. And all the solutions starting from the hardware device, except camera, nothing was bought. And hardware device to software, capturing registration, and then generating a toolpath is done by my colleagues in the Vision group. This is easily facilitate, that will easily facilitate for remanufacturing. You have a component is worn out or the damaged, you can always predict. That is what I think previous speaker also shown. You can recondition. That is the input data you can able to generate with this solution, which we did by in our institute. The another one is, see, we also provide a service to industries on reconditioning. This is one of the example which was developed by Cummins for a Cummins. This is a turbocharger. Our additive manufacturing groups basically reconditioned because this component they were importing, and but the system they don't want it to replace, so naturally they came to us through DED, DMD, that is the direct metal deposition process. My colleagues have reconditioned this, and the broken pieces like it was like this. So finally, we through a deposition we joined. That is a bimetal, right? I think that is a one clear example. So additive manufacturing we have direct applications in the reconditioning or remanufacturing. This is another component again for the DMD machine only we have done for a HAL is a pump gear shaft for a data engine aircraft, sorry, data engine that is used in aircraft. This is again same reconditioned with a very complex shapes. Of course, there are a lot of challenges are there. You need to study both metallurgical aspects and as well as the process aspect, which need to understood. Some of it's not like you just have a machine, additive manufacturing machine, you can use it, because building a product from the powder or the wire as a starting material, it is easy because mostly these machines have a standard protocol. But when you are looking for remanufacturing, is a lot of process understanding is required. And then after doing that also qualification, because particularly these are aerospace components and all, when you're looking for a reconditioning, I think testing and qualification is another challenges. You can't kind of take it granted. But my colleagues have done successfully. We supplied to HAL. Yeah, then as I already mentioned, this is what IoT or industry, smart manufacturing and all. The whole purpose I already told you, to understand what you are doing based on the data and then sharing the data, doing analytics to predict the action points, that you can use action points to solve your problem so that your company will become smart. Smart company means it's basically one has to be innovative, responsive, cost effective, and first to market. That is what the competitive advantage in the market. Okay, I will leave it to you whether it is a manufacturing revolution or evolution. But what are the challenges right now? Industry 4. Of course, in the Indian context is very kind of still not fully implemented. It has not reached to MSME. The major challenges is definition itself is wrong, is not understood. There is no common language, because when you look at an industry, there's manufacturing, even two companies situated in the same area and two adjacent, but their languages are different. And then manufacturing data is an heterogeneity. Say, for example, if you look at a Siemens controller 840, you can able to capture about 48 data, but what you will do with that data, nobody knows. I think that is what the kind of present status now. And there is no standardization, and communication protocols are all developed elsewhere. And still, okay, there are efforts globally, UPI, UC and all, but still nothing is standardized, and each country wanted to add its own communication protocols, including India. And security is still, people have a lot of hard mindset in spite of the technology and all. People are always susceptible. If I put my factory into public network, or what would happen, those kind of things. Then that's what I said, proprietary or personalized. Then still it is not a classroom material. I think very, except barring few institute, I think still smart manufacturing industry 4 is not taught as a regular course. And then capital investment is the major concern, including HR. Including HR means is a retaining the intellectual. These two are the major challenges into industry. But more important is, as of now, industry 4, the business attributes, the final attribute is the ROI. I think it's still ROI is not established in many cases. Realizing this, our Ministry of Heavy Industry, has established, supported 4 centers, 1 center at CMTA and IISc, another is at IIT Delhi, and one more at C4I4 Pune. This is a private group. Kirloskar, fundamentally is a Kirloskar group. You all know this is what IIoT integration means. There are a lot of things to be done. Everything was there. It is not a technology. Now, augmentation of a technology, there are several technologies evolved parallelly or serially. We are trying to use that. Whatever we do, manufacturing value chain, we are connecting through IT, thanks to IT people. Otherwise, it was already there. That means somebody, if say, for example, there is a problem in the turning operation, operator has to call the supervisor or the engineer who sits in AC room. I think that now it is not required. This get alerts. Even not necessary that operator is wanted to know, but this goes to alerts to the mobile of the concerned guy. I think that is what kind of automation happened, particularly with respect to communication in the so-called so-defined smart factory. There are several technologies, so this is just I listed a few, maybe just to have a kind of keywords, so one can always look into that what this means. So we CMT, we have a smart factory. It is a production factory. We are almost like we are off the 50% integration is already done. We wanted to have the smart factory which has some of the legacy machine and also the new machine which already IIoT protocol is built into the machines. And then we wanted to make production factory starting from like loading of material to taking out the product. So integrated with all robotics and material movement, and then controlled through kind of office or the control room. This is a kind of a graphical representation, but our factory is already, it is inaugurated. There's about 50% of the tools are already functioning. While doing this, there are several technologies. We closely work with industry partners. These are our industry partners in our summer center. Each has their own kind of tools. They say, for example, Uttunga is a software company, Indian software company. With them, we are working kind of plug and play solutions, including the platform, IIoT platform, to convert as required to convert your conventional machine into a smart machine. So one can is primarily MSME focused. And then Akumac is just small. They are making a spindle. This company started, I think, bond with the CMT technology 30 years back. So they are number one in making a CNC spindles, CNC machine spindle. Now they wanted to make a smart spindle. So otherwise, you are already knowing Siemens and Hexagon are the global leaders. And HAL also joined us that we wanted to, because aerospace is one priority area. And we primarily focused on our center jointly with HAL, focused on training, imparting a practical based training. We have developed about 8 laboratories, hands-on laboratories, like it's like a do it yourself, that kind of things. Then, of course, since our machine tool area, we are focused in machine tool. So smart, this IMTMA is always behind us. And these companies have joined together with their contribution. It is not that we bought the technology from them, and we jointly develop the technologies. And of course, we expect that with Siemens, we are working on digital twin of spindle and all. But with Hexagon, we are working on digital twin of a smart factory for machining, sheet metal, and additive manufacturing. And with Tonga, we are converting legacy machine into a smart machine. Those are all we are doing. I'll just go through very fast. I'll go just, it is like what is done. I will not get into the details of, because it is all my colleagues directly involved. This is what we do in this center, implementation. That means some of the solutions we have implemented and in the early days as a learning exercise. Then these are the industry collaborators are there. We are working with each one. And this is smart factory demo, training and courses we offer. The sponsored projects, we are already taken up some of the sponsored project. And we also have our own solution, one projects. We have developed about 11 solutions with our own initiative. And some of them are already implemented in the industry as a kind of demonstration case. You look at, this is a machine, which is, we call it as a smart machine. It has integrated with 8 sensor net kind of modules. In true sense, it is a smart machine. All gets compensated, increase in temperature, any vibration. Not only giving an alert, it also gets compensated. And without to the notice of an operator, the program itself gets compensated to ensure the desired quality. I think that is what, of course, we installed 2 machines, little compromised version of this machine because this machine still our baby. Otherwise, 2 machines we installed at BARC, and now technology is transferred to ACE Designer. If you are visiting IMTEX next January, you will see the diamond turning machine, which is developed by ACE Designer based on CMT technology. And this is some of the aspects we converting, how to convert legacy machine into a smart machine. Like that means there are 30 years old machine. This is a machine, horizontal boring machine, CNC machine. This was about 30 years old back, CMTI purchased. So now this machine has been converted into a smart machine to measure some of the aspects. Then there are little details. When we are doing this different, we not only integrating just sensor and capture the data, we are also developing a edge controllers. That means we try to have as much as indigenization solutions. And this is 3D printing. 3D printer is integrated with all the smart tools, sensors and all. And then they have developed apps. This mobile app. You can operate this 3D printing through your mobile. Similarly, this was again one more machine. This is, we have developed some of the tools for this horizontal boring machine, which I already mentioned. Then, as I said, we just not use the tools which is available. Yes, some of the tools will be used, but otherwise we already come up with our own kind of edge controllers, or this is where primarily we work with Uttunga. See, this is one solution we developed for OEE, overall equipment efficiency mapping in the factory. So we demonstrated our factory, our 2 workshops we have. One is a smart workshop here, and another is a conventional workshop. this is integrated, and we will try to map the OE of our factory, our manufacturing system. So wherever the devices is required and all engineered by my colleagues. So this is another this one. This is say for example for energy monitoring. So this is a small device. If you have a machine, so we'll talk to your machine controller and map the energy consumptions, and you can look at the energy consumption, the peak loads, the demand loads, and like there are many aspects. This is also we've developed some of the gateways because when you are working with particularly the conventional machines, age-old machines, it is very difficult to get an access to their standard controller because the old controllers are not having interfaces, appropriate interfaces. So for that, some of the gateways we do, and then we integrate and try to reach to the conventional controllers which are used in CNC machine, or even sometimes we also use external controllers where these controllers, existing controllers, will be used as a switch in a switch mode. And this is again same energy meter was integrated another machine. I think some of the results I'm not going through. These are all captured to showcase that what are the features is possible in this. I think this is implemented in one of the MSME. So there's a edge computer also. These devices are also we developed. So because one can capture the because the reason is data acquisition systems or that interface that to IIoT gateway is an expensive for small scale industry. We have developed, it's cost very few thousand rupees. In fact, you may not believe. So we offered some solutions to MSME at the cost of 5,000 rupees. I think they are very quite kind of happy because that reduced 2 manpowers for them. Right. So I think this is a repetition. I will just skip. Like OEE. So as I said, we are already talked that OPC UA server we implemented. Then through OPA UA, this is what the universal language is getting now. There's a forum, international forum centered around Germany. Some of Indian companies, including our Uttunga, they are partners to that. We are also like, we don't want to behind the developments happen globally. So we are already communicating through UPS servers and all for our OE, particularly overall equipment efficiency module. That will be kind of as equivalent to the OEMs which are offering that services. I think this is a little continuation of that. And some of the analytics also we'll do. There's AI-based analytical tools to, of course, we demonstrated as per our requirement, but it could be customized to the individual industries. And digital twin. So this is, we work with Siemens, as I mentioned. I will not give a little more details as we signed some of the kind of confidential agreement, but the idea is CNC machines has several motors, then stages, drives. This performance has to be analyzed and also mapped in situ, because these are the one which finally imparts directly on the accuracy of the system. Here we are working on that, like developing a digital twin and do the performance analysis before you integrate, manufacturing and integrating into CNC machines. So these are some of the test beds we already physically we are evaluating now. And then digital twin of the factory. This we are working with Hexagon. So already kind of virtual model is already there in the, we have done, but now we have to demonstrate for a complete factory. It would take another 5 to 6 months time to completely demonstrate this concept, what we realized. Otherwise, some of the systems are already in place and we are, my colleagues are working. Okay, there are some students projects we also do related to IIoT and AI based. During COVID, I think one of the students tried to have a image based attendance system. And then IIoT capabilities were also demonstrated. And it is integrated into our reception entry attendance. And this is little advanced area, but we're still working on this. This is the digital twin, particularly the functional performance analysis of a product. I think it is not just a CAD model or doing a simulation of one or two aspects, but we need to study on this. Of course, I can say it is still on the learning curve. But not really done anything on which I can say that it is done, developed. But yes, we are working towards that. Then there are some digital interfaces and VR-based interfaces tools we developed. And we also developed, as I said, a lab. So when the trainees comes, he can easily play around this and acquire the required skill sets. And this is inspection system, smart inspection system. So we integrated in the part of factory. So where Cobalt are all integrated. So basically, we primarily work cobots. We primarily work on that interface, how to interface human and cobots. I think that is what our focus area. But these cobots we purchased, but we are more interested to kind of a technology. That is kind of what we did. So I have only 3 more slides to summarize. This is another activity, like we develop a smart factory, smart foundry, is a metal casting. This project was funded by Department of Science and Technology, where 10 institutes joined together, starting from design to kind of hardwares and sensing and then monitoring, offline monitoring. Idea is to demonstrate the foundry. You may be knowing all the industry for this pyramid is always shown that we just mapped to what we did for 3D printing, smart foundry. We made the hardware, software layer, then the process parameters have been captured by using sensor data. And then this data is being converted into the information and the knowledge through offline assessment. Only thing is smart foundry enterprise management we have not done. Idea is to convert this automated foundry like this to this. This was our initial thought. That means we will build a smart foundry system which is capable of casting up to 1 kg casting, and cost should be less than 25 lakhs, and it could be installed in 25 meters square. Earlier we thought that individual system, but now fortunately we have developed. This is the first casting came out of our individual system, which was built by various researchers, primarily the academic institute. And then DST was kind enough to extend our project. Then finally we arrived this. This is the smart foundry system. This footprint of the machine is 16 feet by 8 feet. It allows you to cast up to 1 kg. Starting from, if you have a CAD data, then use our own software to design the tooling simulation, then send the data to 3D printing unit, which is all part of the system. You print this, then you can make the sand mold and cast it. I think that is what now we have demonstrated. But the idea is to, no matter whether you do in remanufacturing or new product innovation, our always CMTI facilitates in inclusive way. So starting from addressing all these 4 product to process and people and production. That is what, like data to design, innovation to inclusive, cooperate to collaborate, and scalability to sustainability. I think that is what our roadmap, we call it as a DISC approach. This is no matter whether you are new technology development or remanufacturing. I think one has to look into this and customize to individual requirements. Apart from that, yes, we closely work with academic, because I understand many of you are from academic background, academic institutes. So we have an open innovation platform called DIST. You can log in and register. There are several opportunities. Idea is that like bringing problem solver and problem owner together to solve the problem. This is a web-based portal. Already 6,000 users are there. And 2 solutions, we already got it. Apart from finding a solutions and all, there are several events. Almost all our CMT and academic connectivity is happening through this portal. So maybe you can, I request both faculties and students to make use of this portal, make use of this opportunity for internships, project work, and also to solve the problem of industries. Now, 7 problems are open, 7 problems are we hosted. We're looking, industry is looking for a solution. So thank you very much. So we will be happy to work with academic or research or industries, particularly I listed academic, how one can work with CMTI, a collaborative R&D project. We have a CMT academic affiliate program. You pay 2 lakhs rupees per annum, you will get 4 lakhs in return. And we host masters and PhD. Undergraduate students we won't do. Undergraduate students only the internships. Then students and faculty visit. Then my colleagues will deliver the talk. All scientists are allowed to go out and talk to particularly the SNT aspects 8 days in a year. So that means about 62 scientists, 8 days. I think that is what the resource available for some of academic institutes, those who are interested. Then if anybody wants laboratory service, testing services for PhD student or faculties, so we offer a service. We have a discounted price for the academic. And if any institute looking at establishing a laboratory or COEs, because as I said, whatever the solution we do, it works in the field. So naturally, that is the capability, unique capability we have. So if you are looking for establishing a laboratory or these things, I only say don't directly jump and import the equipments. I think there is a capability within the country. We can able to engineer the system. If it is not possible, yes, the thing stops us. We can always import and establish. So I think you can talk to us if anything related to that. We will be able to help you. So thank you very much. I hope.
Thank you very much, sir, for your worthy and enlightening presentations on automation in remanufacturing. You have very well focused that many various works undergoing in your CMTI, and also you have very well focused on the roadmap of for this product innovation and mantras for the transformation. The refurbishment of these turbocharger shaft by the DMD process and manufacturing revolution and smart enterprises. Very well explanation, sir. Thank you very much. And we have a few questions, sir, in the question answer box.
Okay, one is I think this is always augmented reality related to intelligent manufacturing.
It's before I think they are asking. So Rishabh Raj, so 424, he has asked what is the impact of automation during innovative remanufacturing process in circular economy?
Yeah. This is very kind of generic question. Actually, the definition of automation itself varies with the situation. Say, for example, automation is, as I said now, while defining an industry 4. Maybe some of the decisions your computers will take. That is also called as an automation. And say, for example, you have a component which worn out. So if you are computer savvy, so you capture using our image processing, what I mentioned, scanners, you capture the data, build a CAD data, and also use AI ML based algorithm. I will tell you one example which we do. In fact, for the industry, Tata Power Tata Power makes the solar panels. So recently we have supplied a solution to them to detect the defects, identify the defects, and the quantum of damage happened to the solar panel. Say individual cells we do, and then we define. There are different algorithms are evolving. Then you can suggest that either you repair it or you can scrap it. So that itself is an example for reconditioning. So don't, because there is some small damage happened, you cannot throw it out, right? You recondition it. Okay, there is all industry have a different kind of line for reconditioning, but that is what. But another company, we have supplied a service to LMW. There for a textile roller manufacturing. Textile roller as a groups, which is machined out by CNC special purpose machine, which they have in the line. But we developed an inspection system. So 72 images captured, built, and then through AI based, we detect whether this is to be passed or not. I think that is also falls under automation. And at the same time, another very good example for automation for reconditioning, remanufacturing. Similarly, if you look at automation in the mechanical automation is, I will give you one example, but I didn't have we have not reached to the demonstration stage, that is why, but otherwise I can always, what we try to do is a larger dice and very complex dice. Even if you look at the dice and molds, many industries are importing these dice. Even we don't have capability to recondition those dice in many cases. But in normally dice, what will happen is, particularly the electronics goods, the features are very small, and if one insert or one small feature is broken, so many times these dice has to be sent to Malaysia or somebody who is where they imported. So now what we are trying to do is we are building an additive manufacturing machine. It's a hybrid additive manufacturing machine, which can go and machine it out, deposit, again you finish it out. I think that is what don't take it that universally it is possible for all the cases, but these are our approaches. That means our machine will be like additive manufacturing machine for refurbishing a larger die or worn out component. So this definitely cannot be done without automation. Okay, for that we are building a PKM, parallel kinematics based system, not even a robot, because robot has a limitation. When I look at multiple axes, it is very difficult to control. So we decided definitely linear mechanism system will not facilitate. Multi-axis is always challenge, but we are building now PKM based. So I don't know whether I satisfied with my answer, but idea is augmented reality is also the same. Another question was there. Augmented reality is you basically is feeling the process what you are doing. Either it is a metal cutting process or it is an assembly process. And say, for example, there is a component is damaged, pocket is you are looking at a pack, something damaged surfaces. So you can always look at, maybe take the mating part. What is the clearance? Say, for example, there is a bore, is a wound out, and you can always look at a shaft and you feel it. What is the kind of clearance you have? I think there is no kind of alternative to our brain. So naturally, our system is effectively communicate. If you touch and feel, I think that is more important than what your computer system gives the graphs or the pictures. I think that is how we are trying to reach there. The technology-wise, globally, augmented reality is the journey towards that. So in that sense, it is good for remanufacturing. I think I've answered two questions. That was one. And how Industry 4, Internet of Things, smart manufacturing are related to remanufacturing. Basically, I'm confused how these things help us in remanufacturing. I think I request maybe this delegate is don't go with the Industry 4 definition, which is there in the Google. You just Industry 4 is that nothing great. It was already there in the shop floor. How shop floor was working? Shop floor was working like somebody, Rama, Bhima is there in the shop floor. He is an expert. Usually, say for example, I will take you, as you are all mechanical engineers, so I will take a turning operation. If somebody has to turn the shaft, some operation he does, what are the parameters which are accessible to the operator? Only 3.5. That is spindle RPM. You can always set the RPM. You can always set the feed rate, and you can always set the depth of cut. And these are 3 if you have a CNC machines. And other half is that while mounting this one, that is a component, you ensure that this centroid is aligned to the tooltip, all those. But many times particularly the new operator, when you're machining, if he has not done, some chatter marks comes. What he is to do? You will ask his supervisor, or you will call Rama, Bhima, who is an expert in the company, and some chatter marks. If you call for that, he has to go to the nearby phone, and he has to talk to him. And he will, by sitting there, he will, by using his experience, he will align. Okay, you will say, thoda dekho agar centroid TK hai kya, or tool tips broken hai kya. Now, beyond that, he can't do it. Operator cannot do it, but computer can do. So now there are efforts are going on. But if you're mechanical engineer, if you look at just a parameter, one parameter is a surface finish, right? Surface finish of a turned component. What are the attributes? I think I'm sure any of mechanical engineer can list at least 10 to 15 parameters. Now, can you guess that operator, or even for that matter, engineer, can able to compute that and predict? No, it is mostly on the experience based. Now that dependency will go, right? So you can always, tools are emerging and predicting. The desired level is even operator doesn't know what went wrong, but either machine stopped or so that further damage is not happened, or it is like the process parameters compensated. I think that is what the whole purpose of Industry 4. Say, for example, our diamond turning, as mentioned, 8 sensor networks are integrated. So one of them is the thermal error, because this diamond turning machine is creating a features in the order of few tenths of nanometer. Surface finish is 2 to 3 nanometer without any for secondary machining, just by turning. So when you're looking at that accuracy level, each 0.1 degree rise in temperature attributes to your surface finish. So naturally, you cannot depend on the human intelligence. So now what will happen is, if rise in temperature is there, then it gets compulated. It's ANN based algorithm. It is demonstrated. It's working in our machine. Then that compensates the cutting parameters, so that try to bring back to the normal conditions. I think that is what the typical example. I think Industry 4 advocates that. But for us, if you look at Industry 4, say for example, MSME, his requirement is different. His requirement is very simple. I have a vertical machining center. Its machining time is 30%. Do you have a solution, or any solution, IIoT, or whatever you call, which can enhance this cutting speed? And cutting speed means cutting time, actual metal cutting time, to 45 minutes instead of 35%, 45%. I think that is possible with this some of the solutions, right? He doesn't bother the way the company who is having a multiple units and owner wanted to operate, look at, because his requirement is entirely different, and your production guy wants different, and your maintenance guy wants different data. That is what I'm saying. CNC controller now, Siemens can allow you to capture 48 parameters. What you will do, you will not be required even for operator more than 3, because beyond that you can't do anything. And your production guy wants a different, and your maintenance guy wants only the maybe vibration signal that way. I think that is what this technology enables. There are several technologies getting emerged, but universally, no single technology which are now matured enough to adopt directly on the every solution. It needs to be customized, localized, and that is where MSMEs are struggling now. If really ROI is there, ROI has to be identified. What are the opportunity area that is different from one company to another company.
Thank you, sir.
Yeah, I think
question is over.
Also same. Yeah.
Same question. Thank you very much, sir, for your enlightening talk today. So I am very pleased to present the vote of thanks on behalf of our organizing committee. I would like to express our gratitude to Honorable Speaker, Dr. Naga Hanumayya, sir, who has spared his precious time for us and graced this occasion with his vital presence. Thank you, sir, very much for your enlightening lecture once again. Thank you, sir.
Thank you. Thank you very much.
So for these participants, I have an announcement. For the tomorrow session, we have a session 5 tomorrow, forenoon. The session will be on damage evaluation and built metal deposit. So we have 4 presentations forenoon. So I request to all the participants, please join with us tomorrow's presentation. Till then, with this word, I announce the end of this session. Thank you very much. Have a good day to all. Thank you, sir.
Thank you. Thank you very much.
Thank you, sir.
Himanshu, how are you? Hope you are not recording now, right? Yeah. Right then, thank you. Thank you very much.
Thank you, sir.
Hmm.
Thank you all the participants. I will end these sessions now.